Okay, let's take a look at adding and subtracting linear inequalities in this video. And again, we'll start with some examples. Let's go with x plus 5 is greater than negative 1. So really you can treat these as though they were algebra with an equal sign, which is an equality, rather than an inequality. And by that I mean you can do essentially the same steps. So if you were to solve this the equality, you would isolate for x by subtracting 5 on both sides, and that's the exact same step we'll do with the inequality. So if you want to show the subtraction of 5, you're welcome to do that. Otherwise, you can skip that step and just write x is greater than negative 6. Now, when we do inequality solutions, often we want to show what the solution is on that number line. So let's tie that into what we were doing last day by graphing x greater than negative 6 as a graphical representation on the number line. So greater than negative 6, well, here's negative 6. It doesn't include it, and it's all numbers greater than. Okay, let's take a look at a couple more examples. Actually, before I move on, how would you go about checking this one? Well, one of the easiest things to do is pick a value that is in your solution. So we believe numbers bigger than negative 6 are in our solution. For instance, 0 might be in our solution. And to check, just pick a number that's in your solution and substitute that into your inequality to see if you have a true statement. If the statement's true, then your answer is very likely true. So I substitute in 0 in this case. 0 plus 5, is that greater than negative 1? That means is 5 greater than negative 1? 5 is greater than negative 1, so that is true. So 0 is a solution. I could continue to substitute more points in, but it's very nice just to do at least one point as a check to see if you are hopefully in the right direction and showing off the graph in the right way. Okay, let's take a look at a second example. Let's do 3x minus 1 is less than or equal to 2x minus 1. And we'll check it at the end as well. So again, you can do things like add 1 to both sides. You can subtract 2x from both sides. And then we can go and graph this. So I'm working with x values that are less than or equal to 0. So equal to 0 means that this is filled in, and less than is in this direction. So I would believe a point maybe like negative 4 is going to be a true statement if I substitute it in. So let's try that. 3 times negative 4 minus 1, is that less than or equal to 2 times negative 4 minus 1? So negative 12 take away 1, is that less than or equal to negative 8 take away 1? Is negative 13 less than or equal to? And it is in fact less than negative 8. So this is a true statement, and since it's true, I'm pretty sure that my solution is correct. Okay, let's just do a couple more examples. So in this case, I have x plus 3, is that less than x plus 4? Okay, well, let's work through this. So I'll subtract 3 on both sides, and that gives x is greater than x plus 1. And then I subtract x on each side, and I get this weird statement, 0 is greater than 1. Is 0 greater than 1? No. If you end up with an inequality that ends in a false statement, then there aren't any solutions at all that would work. So you can go ahead and check and see if it'll work. Just pick a value. 0. Does 0 plus 3, is that bigger than 0 plus 4? Which means is 3 bigger than 4? Nope. Any value you put in, you can try negative 8. And negative 8 plus 3 will be negative 5. Is that bigger than negative 8 plus 4 is negative 4? No, it's not. There will be no solution possible for our original inequality in this case. So when you work through one of these and you get a false statement, you can simply write no solutions. Now, there's another type of question that's similar to this. Say x plus 4 is greater than or equal to x plus 4, and when you work through this, subtract an x on both sides, for instance. Oh, 4 is greater than or equal to 4? Yeah, that's a true statement. Well, what happens with true statements? Well, let's do a check. What if x is 0? 0 plus 4, is that bigger than or equal to 0 plus 4? Yeah, it's equal. Negative 10 plus 4. Yeah, that's negative 6, and that's bigger than or equal to negative 6 because they're both equal. So if you end up in a true statement, you have all solutions. And all solutions is written as x can be any real number at all. So there are a couple of special cases with these inequalities where you'll get no solutions at all, or you'll get all solutions possible. And we'll see these a little bit this year and throughout the next few years as well, occasionally. And let's come to class ready to practice some of this.